Hello friends, welcome to Unacademy and welcome to today's session. In this session, we are going to learn about the importance of disk scheduling algorithms and what is the role of disk scheduling algorithms and what is the structure of a disk, that means a secondary storage device. The main objective of disk scheduling algorithm is how you are going to minimize how we are going to minimize the seek time and how we are going to see that the effective utilization of your secondary storage device nothing but hard drive. Before entering into the session, let us say our anthem: crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get plus subscription and access unlimited live and recorded lectures from India's topmost educators. About myself, Srinivasrao Sir, having more than 15 years of GATE experience in the stream of CS, having industry experience as a system analyst and database admin with various certifications which are relevant to admin and analyst. Throughout journey of my GATE, I taught in many premium academies, including the GATE Forum, the GATE Academy, and Wani, and many other, including MEDIC too. Many of my students are alumni of IITs and NITs and central universities, and many of my students are working as a topmost software engineers in topmost MNCs. So why can't you? That is the question mark. The answer to the question mark is nothing but get the content from top quality educators or top quality mentors, then you are also going to be chance to be settled as good MNCs. And to get the subscription in Unacademy, use my referral code and enjoy some redeem points as well as. So after applying my referral code, you're going to get a good amount of discount which you can able to use it. If you take the admission in Unacademy, so you're going to get the complete free access instead of a restricted access, that you are eligible to watch all the lectures and all the videos, all the quiz sessions and live sessions which are happening in Unacademy portals. So if you would like to take the admission, use my referral code and enjoy the benefits. There are many batches are happening. There are very recent lectures are also you can able to see. You can also see that live quizzes changes your confidence level to crack any kind of examination. This admission is not only for GATE, it is also useful for PSU interviews as well as general interviews. They mainly focus on C language and data structures and DBMS, operating system and computer networks. These are the core subjects you are going to get questions on them. So if you get admission, then you are going to be land in such a way that you are going to be traveled in such a way that your goal is going to be satisfied. So there are two kinds of subscription. One is a 12 months and the other one 24 months. 12 months fourth year students can able to take, and the 24 months, so my advice is all second year and third year students can able to obtain this. So by taking this, you are going to get n number of sessions, n number of recaps, n number of live test, quizzes, whatnot, all the things you can able to avail. So you all second year and third year students, it is a wonderful benefit to you, such that it's not only for competitive examination, these lectures are also will be very useful to your college level examinations. So you see the university examination, this content is a very much useful. You're after learning these lectures, you will be so confident enough. So if you would like to interact with any kind of a faculty member, just you fill this sheet by entering into this link so that the respective faculty member is going to be allocated to you and he is going to clear all your doubts, either curriculum wise or your professional growth wise, or any kind of questions you can able to discuss. So let's crack GATE CSC. Use my referral code to get the admission and subscribe Unacademy YouTube channel. Hit the bell icon for latest notifications and updates. Let us start today's lecture. What is a disk? So in this session, mainly we are going to discuss about hard drive management. We know that hard drive is one of the important unit for us where you could able to load all your software programs or apps. This hard drive management comes under into secondary storage device. I can also call it as secondary memory. So some people may also say that the secondary memory can also be useful in like a CD-ROM and many other formats. Apart from that, you want to run your operating system in a smoother way, then there is a requirement of compulsory hard drive management. Whenever you have a hard disk, then that is supposed to be managed very well. So how are you going to manage them? We are going to look at in this session. So when you talk about the disk, especially hard drive, which is a consist of many kind of elements together, you call it as a hard drive only. That hard drive is supposed to be managed very well. Why? Because we want to see that efficiency. So we want to see that efficiency of a disk must be high. So in order to see efficiency of the disk must be high, and we also want to see that minimization of your fragmentation. So this is one of the thing or one of the goal, and we also would like to see that minimization of your seek time. So what is the meaning of a seek time? You please see that you want to retrieve some kind of a data from desired sector, then there is a requirement of what some time you are going to take to enter into that particular sector and retrieve the information. So these are the three important main points where you see that exactly we are going to use the management of your hard drive. These are all the important goals you can able to speak that hard drive management only. So when you talk about the hard disk, then the hard disk has got many components. One of the component is a spindle is required, and another component is a platter is required, and the other one is head assembly unit is required, and a cylinder and a track, sectors and clusters. These are all the components you oftenly see, especially in a magnetic disk components. So what is the need of each component we are going to see in the upcoming slides. Friends, you observe what is a magnetic disk? The magnetic disk, if you understand that, which is a consist of what? A set of platters, magnetized platters. So therefore, every magnetized disk you see are having a concept called a spindle. So to this spindle, this is a spindle, and to this, some of the magnetized elements are being connected or attached. So these are called as platters, and these are all called flatters, and this is your spindle. The spindle is connected to a motor. Now once you switch on your system, the spindle rotates. That's calling as RPM, rotation per minute, also called as a resolutions per minute. So the spindle is going to rotate using a concept of RPMs, rotations per minute, as well as resolutions per minute. Now to this platter, if you understand that it is nothing but a plate only, group of plates are called as platters, which consist of outside surface as well as which consist of inner surface. This is your outer surface and this is your inner surface. So you can store your data in inner surface as well as you can also store your data in outer surface. For example, if you look at the CD compact disc, you're going to see only one face only. Bottom face, you're going to store the data, and top face, you're going to have a labelings for them. So what I mean to say that your disk, that means what a platter may have either two sides or may have a single side. But you observe carefully when you are having a surface like this, and these surfaces are connected to read and write head assembly. So they are all read and write headers only. If you are having a single side surface, then there is a need of one read and write header. If you are having two sides surfaces, then there is a need of one more read and write header. So as I am having a three flatters here, all the three flatters are integrated with your read and write heads. And these read and write heads are together is integrated with head assembly unit. Therefore, friends, all the read and write heads are being integrated with head assembly unit. So like this. Now this is your read and write header assembly unit, where you can able to integrate all your read and write headers. So what are the components we observed so far? Please understand, magnetic disk has got a spindle, and to that spindle you are going to connect or attach your flatters, and all platters which are attached to same spindle and rotates at the same speed in a unidirectional. So uni speed they are going to run. So what are the components we are going to observe in the next page? And the first component is a spindle. As I told you, a spindle is nothing but a connecting device which can rotate in a uniform speed, and to this spindle you can able to connect your storage information plates like this. So there are a group of plates which are connected to this, and so they are being called as flatters. So you all may get a doubt that the flatters is the ultimate surface. The flatter is the ultimate surface where your information or data is going to be stored. There's no doubt. So therefore, friends, the spindle keep the platters in a position and rotates them in as required. The spindle keeps the platter at a fixed distance apart and from each other. And disk arm, whenever the spindle is rotating and your platters are also rotating, and disk arm is nothing but read and write header is try to pull the data from your particular platters. Now you observe the second one is a flatter. I can say that where exactly you can able to store, or you can able to read, or you can able to write your data. So now you see each flatter has a surface which can be single-sided or which can be double-sided. If you are having a single-sided, you're supposed to have a single read and write header. Double side means a double read and write header, which means you see, friends, this is your flatter. So which can consist of both faces. Outer side you can store, inner side also you can store, and this has to be integrated with your read and write header. Otherwise the flatter cannot able to move. So this is the representation of your flatter, where you see that outer surface is there where you can store your data outside, as well as inner surface is also there. Now you see data bits are all available on your surfaces only, and data can be retrieved as and when head is trying to pull the data. So whenever spindle is rotated, then the platters are also circulated, so you can able to fetch your data for reading and writing purpose. And the next component is a read and write head assembly unit. We know what is a read and write head assembly unit. We have many flatters like this, and all these flatters we know that they are the mainly storing areas. I can call them as what surfaces, but this surface you want to pull the data, there is a requirement of head assembly. So there is a read header as well as write header. Read and write header composite together, read and write header, so which is nothing but one head assembly unit. So which is going to see that the read and write header is trying to pull your data which is available on your surfaces, and these surfaces are being rotated using the concept of what? Splinter. And that splinter is having a concept called a motor, which is trying to rotate per minute, or you can say resolutions per minute, or you can say that rotations per minute. They are going to rotate in a unispeed. So therefore, friends, all the read and write heads are attached to head assembly. As many platters you have, those many read and writes head come. So this is a pre-designed and pre-allocated. If I am having 1,000 platters in your disk, you see that you're supposed to have internally 1,000 read and write headers which are attached to one read and write head assembly unit. So all the heads must be at the same position while moving. Otherwise, information you cannot fetch easily. Now you see about the next concept called a track. So when you are calling a track, now I'm going to say that this is your flatter. So your flatter has got some surface where you can able to record your data. On this surface, there are some concentric circles. These concentric circles are called as tracks. The best example you can see the hard drive management, your gramophone record only. So your gramophone record cassette, if you observe that there are some concentric circles, or you take your CD, you're going to see the concentric circles. They are all called tracks, and which are part of your surfaces only. That means the surfaces is the part of your platters. And the next storage unit called as cylinder. And what is the meaning of a cylinder? If all the tracks are at the same distance, this is very important point. If all the tracks are at the same distance, then it is called as a what? One cylinder. And how are you going to calculate the number of cylinders? Number of cylinders are nothing but number of tracks per surface at the same distance, not to the different distances. They are exactly at the same distance only. Now the last component is called as a sector. This is very important for us, where you are going to store your information exactly in sector only. So therefore, friends, you see that there are some platters are available. On these platters, you are having a concentric circles, and those concentric circles, which we are going to call them as a what? Tracks. And again, your track is going to divide it into smaller units. Please understand. Your tracks are being divided into smaller units. They are called as what? Sectors only. Therefore, if you are saying that they are all your concentric circles, so they are all called as what? Sectors only. So what the sector is going to store? The sector is going to store a byte of data. Naturally, the default storing capability of your sector is a 512 bytes. So you can able to store a 512 bytes of data. This is what is a concept. So likewise, a track may consist of thousands of sectors. They are all available in your particular track only. Likewise, we are having a multiple number of tracks which are at the same distance, and all the tracks are together. They are called as what? Cylinders. And all the cylinders together is called as a what? One flatter. The flatter has got some kind of a space. Now this is the structure of your magnetic disk. We are having a tracks and spindles and sectors, cylinders, read and write header, motor rotating, and disk arm, and flatters. So platters is ultimate information, where you can see that under platters only you're going to have a tracks, and the tracks are further divides into what? Smaller sectors. Now you see, friends, so the innermost one, it is called as your sector only. Please understand, they are all your sectors only. Innermost one, they are all sectors only. Your sector starts from 0th sector to n-1 sector. Friends, you understand one important information here. This 0th sector is your bootable sector. This is your bootable sector. So if you see that the 0th sector is corrupted, then your operating system is completely down, because 0th sector only the bootable files are going to be stored. So as I told you, the default storage of your sector, the sector can able to store 512 bytes of data. So friends, if there is a question like this, he said that there are two flatters. This is one of your example previous question, two flatters, and every flatter has got two surfaces, outermost as well as innermost, and there we are having a 10 tracks, and each track we are having a something like 100 sectors, and each sector is going to read 512 bytes of data. So now what is the capacity of your disk? So we can calculate what is the capacity of your disk. So nowadays we are calling it as a 1 terabyte or 512 GB, or you can say that 200 GB, 500 GB likewise. So what is the capacity of a disk? If we are calling the capacity, we are always going to keep in the form of 2 powers only, not in the odd figures. So now you see that your capacity using this kind of phenomena, that two flatter, two surfaces, I can say that you are having a two flatters in that two particular surfaces, and that there are 10 tracks to each, and each we are having 100 sectors, and in that I am storing this much data. So finally you see friends, this much kind of information is your hard disk capacity. So your hard disk is going to store this much information at max. Minimum is our wish, but maximum you cannot able to exceed. Why? Because it is being controlled in such a way that you are having only two flatters. But here he said very clearly that on that flatter we have inner face as well as outer face. That means both sides you can able to read as well as write. Now, by learning those elements, we are going to learn about the disk scheduling algorithms. Now, why are we learning disk scheduling algorithm? This is very, very important. So disk scheduling algorithms are very much useful in order to efficiently retrieve your information. You see friends, there are many kind of flatters you are having in disk, use flatters you are having. And in each flatter you are going to have a concept of what? Tracks inside. It's a mandatory. So there are multiple number of tracks are there. In multiple number of tracks, you are having a concept of what? Subdivision. They are called as what? Sectors. So now you see friends, these are all attached to your head assembly. This is read and write head assembly. Now what I want to tell you here, as soon as a spindle rotates them, as soon as a spindle rotates it, and what is going to happen, it rotates very faster. That's the meaning of RPM. Naturally we are having a 3600 RPMs at one round. So it is going to see the 3600 rounds per minute or resolutions per minute. So 1 minute it is going to rotate up to 3600 rounds per minute. So such a speed they are going to rotate, and how these read and write heads are going to pull your data. So that's a very, very important information. Please understand how they are going to pull the data when the ladders are rotating like anything up to 3600 rounds. Here the important thing is that this read and write header, please understand, in this read and write header we are going to write some modules. We are going to write some modules. Those modules are nothing but what? Disk scheduling modules only. Now in this read and write header, we are going to write some modules. Those modules are nothing but your disk scheduling algorithms. So because the disk scheduling algorithms are nothing but one of the modules, so which sector I need to take, which track I need to take, which flatter I need to take, that is decided by this kind of disk scheduling algorithms only. They are inbuilt available as in the form of a module in your read and write header. Therefore, this is a pre-designed software program such that all the read and write header who are controlling your platters which are running with the help of your Splendor. So your modules are controlling with your disk scheduling algorithm. Now, what is the benefit with the disk scheduling algorithm? The benefits with the disk scheduling algorithm mainly two important things. Broadly, you can say minimization of your seek time and a time complexity while retrieving your data from your secondary memory. So you know that secondary memory is a huge, I'm saying a 1 TB hard disk. It's a very huge 1 TB hard disk means what? You can say that 10 power 3 gigabytes you are storing information in that. Therefore, in order to retrieve your information from your CPU, then it is taking a lot of time. Therefore, the read and write headers, please understand, the read and write headers which are there in your hard drive is implementing this kind of a disk scheduling algo in order to see that the time complexity is lesser and the data retrieval is very smoother. So it is minimizing average seek time of the disk, and it takes the decision while selecting the track whether should I select the track or should I leave the track or should I switch over to some other track. So this kind of a selection decision is implemented in your read and write header as I told you, because these read and write headers are being configured with a what your modules in order to choose that which track I need to choose in order to reduce your time complexity. Therefore, friends, there are varieties of disk scheduling algorithms are there in order to see that the seek time is reduced and time complexity is reduced and the throughput is going to be reduced. Throughput is nothing but average number of instructions you are fetching from your hard drive is nothing but your throughput. So these are the main objectives of your disk scheduling algorithms which are implemented in your read and write header. My dear friends, please understand carefully. So the disk scheduling algorithms are being categorized into few varieties. One is based on arrival order, the other one is based on shortest seek time, and the other one is based on scanning completely. So when you are using a component called virus antivirus, you want to check antivirus elements, then the antivirus is going to scan from start of your disk to end of your disk. Such kind of searching or traveling you want, you need to use the concept of what? Complete disk scan. Don't choose SSTF and FCFS. So in order to do antivirus scanning, then we want to see that from 0th sector we want to check for the antivirus program. Therefore, it has to scan from your 0th sector to, because 0th sector is available at track 0 and you're having a many kind of tracks in your particular platters, then it has to go up to your last track, last sector, last sector of your last track. Therefore, my dear friends, then what is going to happen? We are going to check the complete disk from your start of the disk to end of the disk. So when you want to see that all the tracks and all the sectors to be scanned properly in order to fetch your data, then there is a requirement of what? This kind of scanning algorithms. So there are three ways I said. One is the arrival order, the other one is seek time, the other one complete disk scanning. So how are they being implemented? Before learning about those algorithms, I already told you these algorithms are being implemented in your read and write modules. The main objective of them is nothing but what? Minimize your seek time and is choosing a correct track so that I'm going to reduce your what I mean to say time complexity and seek time and increase your throughput. If seek time is reduced, if seek time is reduced, then you see that your time complexity is reduced. When your time complexity is reduced, then automatically your average fetching instructions are nothing but throughput is going to be increased. Therefore, we want to use a proper scheduling algorithm in order to achieve those goals. So, before learn about disk scheduling algorithm, let me give you how they are going to be available. Your request, that means what? User request or maybe a system request. Your request will be in the form of three components. One component is cylinder and the other component is nothing but track. So the seek time is nothing but in order to achieve to the corresponding sector, in order to move exactly your read write header should move. In order to see that the read write header should move exactly to your sector, that time is called as a what? Seek time. Seek time is nothing but the header has to move to the corresponding sector in order to fetch the data which is available in your sector. Therefore, your request is in the form of a cylinder, track, and a sector. So when I say that I'm going to give you some request in the sense it may be in the form of a track or it may be in the form of what? Cylinder. Both are acceptable. So friends, why I want to tell you this, because when you are talking about your disk may consist from start of the point. When I'm saying that start of the point, you see that the starting point is always from 0. This is your start of the point. Or you can also say that it is a start of your disk. It is nothing but 0th sector only. When I'm saying end of your disk is nothing but the last n minus 1th sector, because we are going to start from 0th sector or 0th track or 0th flatter or 0th cylinder, whatever it may be the terminology. Please understand, you are going to start from 0 and you are going to end to n minus 1. So your request may come in the form of three varieties. Either it may be in the cylinder or it may be in the track, it may be in the sector, or sometime it may be also in the form of what? Platters. So using them, we are going to discuss some of the previous scheduling algorithms which are there right now. The first we are going to learn about FCFS. What the FCFS is telling you. So it is nothing but satisfying the request how they are in a order. So it is nothing but what, based on your order only the services are going to be satisfied. So we are calling it is one of the FIFO. So first in first out, or you can say that first come first serve. So we can call it that. We are using a first disk scheduling algorithm in order to see that time complexity of your hard drive is reduced and throughput is going to be increased and efficiency of disk is going to be increased. So therefore friends, you observe that the disk consists the tracks in the range of 0 to 99. So with this is starting, this is your start of your disk and it is going to ending point of 299 is specified. So we are having, this is a end of disk. In between we are having a many kind of a tracks. It may be all the tracks which are belongs to one particular flatter, I don't mind. You see that on your flatter there are many kinds of tracks which are available. Now you see in that there are some requests I want to satisfy. So these are the orders the request has come from your particular system. And now I said that head is playing a very important role, because head is only trying to retrieve your information. So read and write header is very much needed for us in order to perform read, in order to perform write. That's why we are having in head two important units, read head as well as write head. Now you said that this read head and write head. So read and write head initially at 0. Then afterwards it's moving to 1, then afterwards it's moving to 2, afterwards it is moving to 3, and it right to goes to the last disk, that is not last track, that is a 99 track. This is how it is going unidirectionally from one particular way to other particular way. But some of the algorithms are also telling you that you can also have a bidirectional traveling. But as far as FCF is concerned, I am saying that we are learning in a uniform traveling only. So what is the uniform traveling? Whenever you start from here, like your tape cassette only, I can have forward, I can also have a rewind. Forward means what is going to largest track side or largest sector side. Rewind means it is going to smaller sector side or smaller track side. So when you are talking about the track, this track is having a two important things. One is a what? Smaller one, and the other one is a what? A larger one. So now you see your read and write header. It may move towards to smaller side or it may move towards to larger side. This information the examiner is going to put us. Now to this we are going to satisfy that how many number of or you see that average number of tracks you visited or what is the distance you traveled, this kind of questions he may ask you. Now I will show you average number of tracks it is being traversed after satisfying these are all the request, or what is the total distance it traversed in order to satisfy these particular tracks. Now friends, so let us go. The head is right now it is 53. What is the meaning of 53 means? It's almost all satisfied some of the previous request. Exactly it is locating at 53. So I pause it. When you pause, that particular point is called as what? The head is readily available exactly at that particular time. And to that there are, I said that 0th track or a 0th sector is there and n minus 1 track or n minus 1 sector is there. In middle your header is locating here. Now there are some requests have come from the user. What the request have come? 98 to 183. So we have to write them because when you talk about the disk your particular track numbers are always in ascending order only from lower to higher. So I'm going to write whatever the request you are asking, I'm going to write in the form of what? Ascending order, because I cannot write all the 0 to 199 to 1 track. So whatever the request the examiner is giving you, those requests I am going to write in a proper order. So the requests are coming as like this. So 98, 183, 37, 122, 14. So 14 is the last one. So I'm going to write the 14 is the last one. So 14 I have written. Then after the next least one, so we have got 37. So I'm going to write 37 now. Then after that next least one in ascending order, then we are having a 65 and a 67. 65 and 65 is after your 53. So 65 and a 67. Then after that we are having next 98 and 124, 98. And after that we are having a 124. Then after that we are having 122, 183. So 122 and 183. So 122, 124, 183 and 199th one is the last. Okay friends, so these are the tracks which we have recorded in ascending order. Now you can start satisfy. Right now your read and write head exactly is at 53rd track. Now your request, however your request are come in the same order we are going to satisfy. The first request you have received 98 and 193. So immediately head goes from 53 to 98 and from there it is going to cross check 193. So this is a second request. So we have got completed first 93 over, 183 over, next 37, 122. So next 37 it is going to satisfy in the order. Next we are having a 122 here. Then after that we are having 14 and 124. So 14 again we are traversing and 124 we are going in a forward direction. And again after that we have 65 and 67. So we are coming back, rewind, and we are going forward. So finally this is how the scanning is being done based on FCFS. You see that FCFS is one of the easy approach, But what is the drawback in FCFS? Always drawbacks only. What are there? You see that the total number of tracks you visited or average number of tracks you visited or average distance is going to be very high as comparatively to other algorithms. So how are we going to record them? So I'm going to record them directly. You started at 53 and you went to 65. So 53 to 65. How many you visited? We want to record. Next. So before that, first your request is 98. So we are going to take the first one as 98, not the 65. So first request is 98. Then from that 98, we have moved to 120. We have moved to 183. That is our next request. Then from 183, we have moved to, so from here, your head, read and write head traversing in reverse side. That means what? Head position is reverse. Here head is going in upper side, then head is reversed here. Sometime you will also ask that the reversal positions of your head. So head is reversed and it is going to satisfy other order, that is the 37. Now here also head is got reversed, that reversal points need to write. So head is reversed and it is satisfying 122. That means from 137 to 122 we want to record. Then again head is reversed. So it is going to satisfy next 120 to 14. So again head is reversed. Then it goes to 124. 14 to 124. Again head is reversed. Then we went back to 65 from 124 to 65. And again head is reversed. From 65 we went back to 7. So this is how, friends. That means what? By satisfying it, after satisfying two requests, here no reversal header. So after satisfying from next, head is going to be reversal every time. So you need to write them that how many units you need to travel, summation all of them, and divided by your total number of requests, you are going to get a what? Average. So how are you going to get the average tracks visited or average distance you visited? Average tracks visited is nothing but total distance by total request. First, you are going to get average number of tracks you visited or average distance you visited. So we understand that the main drawback in FCFS when you are talking, this is only, what is that? Average distance is very much. Average distance is more than any algorithm. That's why we cannot implement this than any algo. So we are going to reduce this. How are you going to reduce this? We have shorter one. There is always opponent to your first come first serve is nothing but shorter one only. So shorter one is telling you that a shorter nearby track. That's the meaning, nearby sector or nearby track. So when you are having a nearby track, I need not traverse that much to pull your request. So I'm going to satisfy my nearby sector. Therefore, your seek time is going to be reduced. So what is your seek time? I said seek time is nothing but time takes to visit a sector or read and write. For reading and writing your information into your sector only, because your sector is only consist of original information. So this seek time you want to reduce, then you can able to reduce using the nearer track first. So what is the meaning of that? Select the request with a minimum seek time from your current head position. Okay, friends, but it is going to give you some kind of starvation to other request. That means what? The tracks which are already entered, we are not going to satisfy. We are going to see that the shorter one only. So we are going to implement a concept of what? Shorter scheduling algorithm. From that we are going to see that which is the shorter, then we are going to fetch the data from it. So how does this is going to work with the same example? We will see now. So same example, if you consider, now I'm going to use in favor of shortest seek time first. So this is as far as FCFS, how we traversed all the tracks in order to fetch your information which is there in your tracks and which is further divided in the form of sectors. Now we want to see that how SSTF is going to pull the information from this kind of scenario. So as usually, we have the scenario like this. So we have same kind of a tracks, and this time I'm going to choose the nearby track first. So by taking that nearby track assumption, we are going to pull the information. So right now we are going to work with SSTF, shortest seek time first or nearer track first. So head is right now at 53. So I need to check every time this kind of smaller scheduling algorithm, which is a shorter track to me, or I need to find the shorter distance always I need to find. So 53, if I'm going this side, I'm going to get a more tracks. If I'm going this side, I'm going to take a more tracks. Therefore, 53 minus 37, I need almost all 16, and 53 to 65, I need almost all 12. So I'm going to satisfy 65 only. There is a small effort is also required. What is that effort? You need to always seize that which is the shorter track. That kind of work you're supposed to do. So therefore, head is right now at 53. Exactly this point, it is satisfying because I need only 12. So if I going other side, I need somewhat required more than this. Then after that, right now the head is at 65. That means it's already scanned. Its information is fetched. It may be audio, video, or image, or it may be any kind of a file. Now head is moving towards that side only because I need only two. If I go left, I am taking more. Then that is 7 to 98 if you consider there is a requirement of almost all 31. So 31 tracks I need to make a journey in order to touch your 98. So if I come back, what will happen? If I come back, I need only 30 because 67 minus 37 it is 30. So I will satisfy this. After satisfying 37 to 14, I am going to satisfy because that is my nearby track. From that 14, again I will go and satisfy your 98, and from there I'm going to touch a 122 and 124 and 183. You're going to stop. So this is going to be the next starting point for next upcoming request. It is exactly stopped at 183. After that, this is going to be given as your history to next level request. Now, if you observe SSTF carefully, so the advantage I already told you. What is the advantage is that number of tracks visited are very less. That means what? The distance traversed is less than your FCFS. That's why we are always prefers among all the algorithms, whichever is the best prefer one, we are going to choose a what? SSTF only. But what is the problem? Every time you need to compare among the two tracks, which is the shorter to the current head point. That's very, very important. That is one of the negative side. But the remaining side is a what? The distance it travels to all the tracks is going to be very lesser as comparatively to FCFS. Now you see the next kind of algorithm, if you understand that these two algorithms, one is based on one is based on arrival time and the other one is based on shorter seek time. So these two, that means what, when I'm discussing about FCFS or when I'm discussing about SSTF, the only they are not going to completely scan the disk. Please understand. The above are not completely scan the disk, are not completely scan disk, scan the entire disk. So based on your request only, you need to say that. That means what? See, while you are doing antivirus execution, so I am running antivirus to check the viruses. It will give you few options. You want full scan. This is one of the important point. Or you want C drive, or you want D drive, or you want any kind of a folder. What is the meaning of this? The a disk you are visiting, the tracks you are visiting, or the sectors you are visiting. If you are saying that full scan I am doing, then full scan means what? It is going to do scanning from your 0th sector to the last n-1 sector. So in order to do full scan, you cannot use FCFS and SSTF algorithms. So therefore, these two are certainly not possible to do complete scan of your system. You want to do complete scan of your system, especially fragmentation. Please understand. Whenever you want to see that some sectors are unidentifiable, that's called a fragmentation. When I'm talking that, please see fragmentation in the disk you want to use, then you cannot use this FCFS algorithm and you cannot use SSTF algorithm. In that cases, you want to identify that the bad sectors which are there in your disk. Fragmentation is nothing but what? Rectifying your bad sectors only in this aspect. So you want to identify a bad sector identification in your Windows operating system or Linux operating system. You are having in Windows operating system or Linux operating system, you're having a concept called what? Fragmentation. If you give the fragmentation feature, then it checks for the what bad sectors. Automatically, they are going to be rectified sometime, but sometime it's not going to be rectified. When you see that 0th sector is spoiled, that's it. You can throw the disk away because 0th sector must not be spoiled because your operating system files are being available from 0th sector only. If 0th sector is not possible to repair, then you can able to throw the disk. It is not possible to use it. That's what. In that case, you want to see that complete scan I want to do from 0th sector to n-1 sector. All the flatters, all the tracks, all the sectors I want to visit. And you have to use the concept of what? Scanning algorithms. In that case, we are going to use the scan algorithms. The first scan algorithm, if you understand that elevator. So please understand here. In scan algorithm, it's like a stepping only. So going towards either upper side or lower side. Escalator going to top floor or coming down to the down floor. It's like a escalator, and so it is called as an elevator. The advantage is that once you start using a scan algorithm, I said already these are all the algorithms are being well built in a read write head module. In read write header, there are some modules. These modules are inbuilt having scan scheduling algorithm. That means what? Disk scheduling algorithm. All your disk scheduling algorithms are inbuilt with this read and write header only. Nowhere it is going to be available. So that's we need to write such a program that we are having right now these many algorithms, but still you can do R&D in order to better improvement than your algorithms. These algorithms are there since 100 and 200s of years. So you can do R&D and build a good particular disk scheduling algorithm. So come back to this. Now you see the disk arm is nothing but read write head only. So it is going to be one end of the disk and moving to other end of the disk. The servicing request all the so whenever it is a come across, and it is going to satisfy all your request. So one important thing is that, for example, you see it satisfy track 1. First we have to come with track 0 and track 1. So wherever it come across some kind of a request are there, then immediately it is going to service. If you not ask, then it is not going to service. If you ask, then it is going to be serviced. That means whenever the head is moving, this is your head, it can move from reverse side. That means what? A rewind side. It can move in a forwarding side. Both sides you can able to have. So forwarding side you can move as well as rewind side you can move. That means whenever it is moving your, so you can do what is meant to say play and pause. Play and pause is nothing but when I am saying play, for example, your tape recorder cassette, if you understand what is a tape recorder cassette, first you see you need to insert one cassette inside. Now there is a read write header here. So when you press it, the header will exactly fit to your particular cassette. Then automatically inside element is going to be rotated. When it is rotating, then this particular black concentric circles are being given to here. So it is going to be increased whenever it is playing all the things toward right side. So whenever this particular tape has come to this read write head, it fetch the information and gives to you. Therefore, friends, what we are going to see that the read write headers are not going to be moved. Please understand. No element is going to be moved except your spindle and your flatters. They are going to be rotated. Your read write head is a fixed position only. So whenever it comes here and it try to fetch some kind of information, the similar mechanism what you are using in tape recorder cassette. So here what is going to happen whenever they are moving, then I am going to do what? Reading the information. When I say that I want to play, when you want to that play is nothing but you are giving a request to scan the information. If you are not playing means what? That is simply what? Going in a forwarding direction. That's nothing but what? Fast forward and fast rewind. You are not interested to watch anything means simply you say fast forward and rewinding only. But when I say that pause, when I say that play, that means what? You have given a request to the system. I want to read the content from there. Here play is nothing but one request. Please understand. So I have given in the previous example some of the track request. Some of the track request is nothing but what? Your information is spread over in randomly and there are some tracks are available like this. When I am saying some play means what? One request. Again, 14 to 37, I am not interested to watch the data. Please understand. So this is my first play, 14. Then after that, I want to watch the song or video which is there at 37th track. So I have used fast forward. When it comes to 37, immediately I played it. When you played it, then that information is going to come. And again, I am doing fast forward. When you are doing fast forward, I come to 65. So I want to release it. When you say that play, again the information which is there in 65th track is going to be retrieved. That's the meaning of user request. User request is nothing but you're asking to fetch some information from there. In our regular term, we are calling it as what? Pause and play and fast forward and rewind. So what the scanning is telling you here. So scanning is telling you here that you can able to go from one particular direction to other particular direction. Here two ways you can able to go towards to lower sector or lower track or towards to higher sector, higher track or higher cylinder, whatever it may be. So based on that, we are going to satisfy this problem. So the problem is like this. So this is as far as SSTF concerned. Now we are going to do as far as scan concerned. So scan two varieties. One is you can do circular way. The other one you can do non-circular fashion. Non-circular fashion means what? Vertically. You are not going to rotate yourself. So right now the head is at 53. Now the head can move towards to left side as like this. Head can move towards to left side. Or head can also move towards to right side. So when I am moving left side, I am writing a scan with the left. And what is going to happen? Head is moving from 53, head is moving to 37. So you already given a request that I want to watch something from 37th track. So you know some songs you could able to see while you are watching some kind of CD disc or hard disk. So 37, I ask the play, then it is playing. Again, the head moves to other side. Just it is moving only towards other side, and there is a user request which comes for 14. Then it's played there. Then it enters into starting point. After that, we are rewinding. So it is coming to other side. Whenever it is coming to other side, this is your last request 183. So it satisfies this request. It also 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 satisfies this. It also satisfies this. And now stop. So you have stopped the point. Tomorrow you switch on your system now or a TV now. Then tomorrow you on once again the same movie. Your movie will start from only that particular 183 point only. Why? Because this is very important. Wherever you have left your head position, from there only you are going to continue your movie. All smart TVs are working with scan algorithm only. Please understand. So it goes starts from start, and wherever you leave your head position today, and from there it is going to continue your next request only. So your exactly head is stopped here. Next request onwards, it is going to be seen that it's going to be start from 183, not from 53. Okay, this is about scan towards to left side. But I am saying scan towards to right side. So same policy we are going to follow. This time I am traversing towards to larger side of your disk, not the lower side of your disk. So examiner will tell you this information to us which side you need to traverse. So I'm traversing this time scan towards to the right. Now you see this time head is he said that 53. I'm forwarding this time. So while you are forwarding, head is going towards to upper side. Then whenever it finds some request, immediately it is going to scan them. As and when reaches to its end, then it is going to come to the reverse position. While reverse position also whatever the tracks it find, it is going to satisfy there. So this is how it able to see that the complete scan is going to happen in this case. But here the problem with the scan algorithm is only one side only you are able to touch the disk. Either starting point you are touching or ending point you are touching. You are not touching both sides. You want to see that both sides you want to touch, then there is a requirement of what? Circular scan is here. So what is the advantage with this scanning algorithm? Please see that this is a real-time implementable. SSTF is not real-time implementable. FCFS is real-time implementable, but the problem is that what? So much more distance is that. But the real-time advantage with scanning algorithm is see that it's a very faster first one. Very faster and real-time implement. You can implement real-time. But why I'm saying it is very faster? Because see, actually people are guessing that shortest seek time is going to be very bigger one. That means what? It is going to see that very faster because it is going to satisfy nearer track first. I do agree. But really it cannot be implemented. So real-time implemented one scanner is better than anybody else. This is a real-time implemented one. But what is the problem here? The only one problem is that so you are traversing from starting of the point to ending of the point. Now you see the other variety is a circular scan. So what is a circular scan? You know that we are going to get a chance after satisfying so many number of things. So 0 here, 1 here, 2 here, 3 here, 4 here, 5 here. So first I am starting 0, then 1, then 2, then 3, then 4, then this. Then after that, after ending to your particular day, this is ending point, this is your starting point. Please observe. So you need to scan everyone. You need to scan everyone. Then once you reach to ending point, then only you can able to go to what? Starting point only. So you can say that uniform service request is a concept of what? Circular scan. So it provides more uniform wait time. Then what is the mechanism here? The mechanism here is nothing but let us execute it and see that what is the importance of this. Now I am executing through cscan. So here also you need to record two important information. One important information is that starting of the disk and ending of the disk. So I am taking a starting of the disk one point and ending of the disk another point. So 0 is my starting and 199 is ending because he said that we are having a 200 sector starting with 0 and ending with 199. Now you see head is at 53. I can move towards the left side or right side. If I am moving right side, what will happen? So I have satisfied. I am going in a circular fashion. Please understand, circular fashion I am going. So I am going to get after servicing all your requests and I touch to 99. This is your blank. You are not having any kind of information. From there, I come across to touch your zero. That means starting point. That's what is the meaning. So you have to entirely rotate your disk. Again, you come to the starting point only. From there, you try to satisfy your remaining request. You see that you are not going to have bidirectional request satisfying. So however you start your work, it is going to be scanning in that linear fashion only. We are scanning towards right hand side. So we need to travel. This is the drawback. What is the drawback? The other side, the head, whenever it is moving 199 to 0, I have moved. These many are your blank sectors or blank tracks. So wastage, so unnecessarily you are traversing much more distance. But the advantage is very high. In order to do a concept of what complete scanning you want to do, you better use a circular scan only. So circular scan you are using in antivirus programs and virus checking programs, and as well as I said that searching of bad sectors using a concept of what? Fragmentation. So fragmentation is going to use the concept of circular scan only. The other two kinds of algorithm, the drawback we understand, it is having a much more distance than your normal scan algorithm because we are doing one kind of complete rotation. And the last kind of algorithm is a look. So look is very similar to scanning. Look is nothing but what? Last pending a request in the direction of read and write header. It's very similar to scan, except that we are not touching your boundaries of the disk. That's very, very important. If this is a 0th track and this is your 199th track, I'm not going to touch these boundaries. So wherever there are a request are there, those requests only the header is going to be moved. The header is going to be moved whenever there are some kind of a request. It is not going to be moved apart from your request boundaries. This is your request boundary. This is your request boundary. We are not going to touch your starting and ending point of the disk. This is one of the best advantage than your scan. It's very similar to what? Scan only. The other alternative variant of your scan is nothing but a look algorithm where you are not going to touch your starting boundaries and ending boundaries. So you see that the same. So on this disk scheduling algorithms, we have got a questionnaire tomorrow at 6 p.m. Don't miss. 6 p.m. we are going to do questionnaire on YouTube. Don't miss this session. There are some questionnaires on disk scheduling algorithm and a file allocation table from yesterday's session. And tomorrow you are having a 2 p.m. There is a complete quiz on entire operating system. Don't miss. Even you know some of the questions, please attend so that the question may be asked in different way. That's why don't miss tomorrow's session. 2 p.m. we are going to have a complete quiz on entire operating system. And at 6 p.m. we are having a what? The questionnaire on complete disk structure and disk scheduling and file allocation tables. Don't miss tomorrow's session. So quiz I'm going to conducting on Unacademy student learning app, and this questionnaire we are going to do on YouTube lectures. Yeah, Mukesh Kumar, please wait. Let's see. And we have look algorithm now. So what is the look algorithm? How it is going to execute? Let's see. Now we are going to erase this. So I'm going to work with the look algorithm. Now there are two boundaries are given to us. One is a starting boundary, the other one ending boundary. We are not going to do starting and ending boundaries in look algorithm as well as C look algorithm. It is a completely different approach that we are not going to traverse starting and ending point. There is a boundary we kept. What is that boundary? Starting of your request to ending of your request. This is only your boundary. So based on your request is going to satisfy. Now head can move towards left side or right side. Both sides are possible. If I am traversing towards larger side, so it is satisfying. But it stops at 183. It's not going to touch this particular part. That is our savings. Now while coming back, it is going to satisfy these two. Now it is going to stop. Therefore, there is a boundary between your starting of the track to ending of the track. This is your look algorithm, and the head is moving towards to left side. And we have the other algorithm called C look. C look is very similar to C scan, circular look. So what the circular look is going to do, please understand. Very similar to look algorithm. We know that disk arm is not going to touch your starting boundary to ending boundary. And we are going to see that uniform scanning, bidirectional scanning is not there. That is only the one point. So friends, how it is going to be executed. So this is executing like this. Let us erase once. So we are executing circular loop. Circular loop we are executing. Let us erase these entries. So we know that we are not going to touch boundary of your starting as well as ending. Assume that head is going towards to right side. Therefore 53 you are right now. So it's satisfying 98 and 122, 124 and 183. Don't forget to write your all entries in a ascending order. Otherwise it's going to be mistake. First to write your tracks in ascending order. Then only you try to do all your kind of algorithms. Otherwise read write head is under confuse or ambiguity while you are giving mixed order. Please keep your request in a proper ascending order. Then you give task to the head, the read and write head. The read and write head is implementing what? Disk scheduling algorithm. The aim of disk scheduling algorithm is that which track I need to choose for the execution. So while implementing a C loop, it's not going to satisfy reverse. You are traversing in the other side towards to upper side. So when it comes this boundary, it satisfies this and it satisfies 37. That means friends, what do we understand? From this particular point to this particular point, we are doing a what? Blanks. Simply the head is moving without satisfying anything. Just you kept a rewind. When you are doing a rewind, the tape is completely scanned to others. Once you reach to this particular point, then you release it for play. Releasing for play is nothing but you are giving a request to fetch the data from your particular read and write header. So this is how CLOOK algorithm. So friends, here I want to tell you one final information before closing this. The final information is that we understood the disk structure. The disk structure, you want to see that why we are learning a disk scheduling algorithm in order to minimize your seek time and in order to minimize your time complexity, in order to increase the efficiency of a disk so that throughput can be increased. That's what the main goal of a disk scheduling algorithm. Who is going to do disk scheduling algorithm? Operating system. It is going to have a concept of a disk structure. Your disk is completely integrated with read write head assembly unit. So in that read write head assembly unit, so in that read write modules only, we are having a modules. It's a software module only. It's a software module which is going to see that what kind of a track I need to execute it. Therefore we are having a modules here. These modules I have given a 6 varieties: FCFS and SSTF, and we have scanning algorithm, 2 flavors, and we have look algorithm, 2 flavors. Please understand friends, so the disk structure before closing the session, observe there are many flatters are available on your disk. The flatter can be having a 2 sides, topmost and bottommost. I don't know how many of you are knowing that earlier we used to have a compact disk where you can write upper side as well as bottom side information. But right now in CDs we are able to write only lower side only. Upper side we are not going to write. So if you are having both the faces, you need to have both the read write heads, and these read write sets are being controlled with your head assembly. So the head assembly consists of all your read write heads together. Head is not move. Please understand, head is not moving and your flatters are moving. So who is going to make the flatters to move? This is very important. Your flatters are moving only with the help of what? The spindle. The spindle is controlled with your motor, spindle motor, which is going to use the concept of what? RPMs, rounds per minute or resolution per minute. By default, we are having a 3600 resolutions per minute. So with this fast retrieval, we are going to use the concept of what? Disk scheduling algorithms in order to increase your efficiency. Friends, you please see that one important announcement for tomorrow's session. Tomorrow we have, don't miss this, 2 p.m. onwards on Unacademy student learning app. On Unacademy student learning app, I am conducting a quiz marathon session for entire your operating system. Please utilize this opportunity. You may be known some of the questions, but some of the questions you may not be known. That unknown question you're supposed to learn for the examination, because this time the syllabus is reduced by IIT Mumbai. I hope so you people might be aware of it. And we are having a tomorrow 6 p.m. session. This is I'm doing on YouTube. Questionnaire on disk scheduling algorithms. Please don't miss. Not only disk scheduling algorithms, we are having a questionnaire on file management system also, like inode and others. So inode is a very important technique. We learn tomorrow disk scheduling algorithm as well as inode, which is at 6 p.m. and 2 p.m. is on quiz session. And day after tomorrow onwards, I am conducting computer networks classes. This is the next announcement for you. The computer network classes will begin. So some I am doing on YouTube. Please understand. Some I am doing on YouTube, which is from 2 p.m. it starts. If there is any change before day, I will inform. But next immediately we are going to start this class. So 2 p.m. maybe Tuesday I am thinking. So Tuesday onwards you are going to have a computer network classes on YouTube. And I am going to conduct plus courses and plus courses. I'm going to conduct DBMS. So those who are plus students, non-plus students can carry forward your computer network classes on your YouTube. And those who want to become a plus course students or those who already plus course student, I'm starting your DBMS subject, which is going to be completed in 3 parts, part 1, part 2 and part 3. This is only for plus students, not for the non-plus students. And a computer network, all can able to watch these sessions, very important sessions I am doing, as I am a Cisco certified. So you know that I am a having a good grip on your networking real-time experience, and I am a DBA. That's why I able to have a good experience in DBMS subject also and OS 2. Please see that if you are having a free time, you please give your Cisco certification, and you also please write your DBA certification. You also please write your Red Hat or Microsoft certification. These certifications are very helpful to you in real time. You want any kind of further guidance, please join into Plus. There I am going to guide them how to write your certification programs and how to pass them very easily. Okay. And one of the friend asked one doubt. What is the doubt? This is the doubt the friend is asking. Kish Kumar, are you there? Yeah. So what is the doubt? Please understand. So there is a one entity and there is another entity, and we are having a concept of total participation both sides. We have total participation both sides. This is the relation 1. So how many tables? This is what is the question. If it is a 1:1, we know that we can say that one table. Why one table? Because this primary key we want to join here and this primary key we want to join here. Observe friends, one real-time scenario I'm going to tell you. This is one of the question of one of our plus students named Mukesh. And if you are having the concept of a total participation means naturally it's supposed to be 1:1. many participation. This is real time needed. This is real time implemented. Remaining all are false. They are all only practical questions only. Sorry, they are all theoretical questions only. They cannot be implemented practically. So when I am saying that total participation in the sense one entity is completely depends on other entity. I am saying E2 is entity and I am saying E1 is an entity. When I am saying a total participation here, this E2 is a completely depends on E1. So this is the real time scenario. What is the real time scenario? One entity depends on another entity. You want to say this side is a total participation, other side is supposed to be one relationship, because the primary key we need in order to see that you are the dependent to me. Therefore what is going to happen? You have to depends on me this side. So while you are depending on other side, the other side is supposed to have a what? Dominant entity, not the subordinate entities. Therefore, this side is totally participated, this side is supposed to be partially participated. If you are doing a total participation means the subordinate is going to be depends on dominant entity. Otherwise, it's illegal and invalid case. So real time you say Aadhaar database with the customer database. Aadhaar database is dependent on customer database because every customer may or may not have Aadhaar, but every Aadhaar is supposed to be recorded into your customer side. So that's why real time implemented, this is how we need to implement. What is that? This is a one, when I say total participation, every total participation must be depends on your primary key, otherwise it is invalid. But sometime the examiner may ask you questions like this. If both sides in 1:1 this is right, why 1:1 this is right? Both sides I am having a primary key. Please understand. Both sides I am having a primary key. This also I am having one is nothing but primary key. This also I am having one is nothing but primary key. Therefore, two primary keys are there. When I am saying a two primary keys, both are strong entities only. They never become a what? Subordinates. Please understand. Mukesh Kumar. So when I say that primary key both sides are there means both are having a primary key, and I can say that both are what? What I mean to say, dominant entities only. So even you merge them, they all together what? Dominant entity. E1 itself is a dominant entity and E2 itself is a dominant entity. But while you are talking many to many relationship, when I am talking a many to many relationship, we need to understand one important thing. What is that? Every many is a one is to many, and every many is a one is to many. Therefore, you cannot able to merge all together. So there is a mandatory requirement is that when I am saying a many to many relationship here from the between two entities, whatever may be the relation you take. So this is R I am saying. I am saying that many to many relationship, which means here to here one part and here to here another part. They are two different entities. One means what? Please understand. Means what? This E2 is acting as a 1. This relationship is acting as a M. And this E2 is acting as a 1. This relationship is acting as a what? M. Now, this relationship is containing a what? M is to M together. Therefore, you cannot able to merge together as they are not independent tables. Because this is M, this is M. They are not a single ones. That's why this is requiring a what? Primary key, and this is also requiring a what? Primary key to me. Therefore I can able to write a what? Foreign key status. But in 1:1 you can able to merge all together. Why? Because both are having a what? Primary keys together and they are going to be act as a foreign keys. But I cannot able to locate here. That means what? These two primary keys I cannot able to locate into what? Two foreign key system. Here I have a two foreign keys, but there I have only one foreign key system only. Because when I am saying 1:1 relationship, either I can able to keep this into this side as a foreign key, or if I am saying this side into this side as a foreign key. But how you can able to combine these two foreign keys together? It's not possible. Therefore, when you are having a many to many invalid case, that is what both sides total participation is there, you cannot merge them. Therefore, this is the entity E1 and this is the entity E2, and you are saying that this is a total participation, this is the total participation. I want to see that both the are dependent on each other. It's an invalid case in order to In order to prove multiple foreign key relationship, it's not possible. That's why we want to see that in such case, we want to create this separately, we want to create this separately, and we want to do, what is that? One is to many relationship here. We want to do one is to many relationship here. Therefore, I'm going to call it as a what? Separate entity in this. So this is a normal case where you can able to do what? Separate table creation in the event of what? Many to many. Merging is only for 1 to m and m to 1 and 1 to 1. And please attend all of you, please share this information, Mukesh Kumar. So tomorrow I'm going to conduct 2 p.m. quiz. If you are having a time, please visit on Unacademy student learning app. And tomorrow 6 p.m. I'm going to run YouTube session on that. Please subscribe to me. And day after tomorrow onwards, we are having a computer network classes. Don't miss. So I hope so I can do better and best to all of you. Okay. Thank you very much.